So I decided for my laser tag circuit, I wanted to use RFID instead of, separate buttons on there. And in order to do that, I had to actually figure out how to get this RFID to work. So I got this RFID scan chip. You can get this from a lot of different places. I got it from Amazon. It was about $6, and there's a lot of code that's written for this particular receiver, so that was kind of nice. That there wasn't something that did specifically what I wanted, so I'm going to go over what it is that I wanted it to do, because the only thing that I wanted this to do was to be able to recognize a specific RFID card. So there's plenty of programs that you can download that will, and I can show you those two later, that let you read the RFID card and write to the RFID card, but I just wanted something where if I scan the RFID, it will trigger something else to happen in the circuit. So this particular card came with two chips, two tags, so there's one chip in the card and one just in this little keyring. And what I wanted to do was look up the ID for each one of these and then have it control something different. So if I do the blue keyring, it's going to make the red LED light up. Oh, I actually have to upload the program again. And then if I do this card, I want it to have the blue LED light up. So two different cards to do two different things in the circuit. So that just lights up the red LED. This one will light up the blue LED. And that's all I wanted it to do. And this is, pretty much the most simple thing that you can do. And I get the impression from a lot of the other tutorials that, this simple thing was embedded into more complex things, but I didn't understand the other complex things, so I just wanted it to do the simple thing. One makes one light go, the other one makes another light go, and then once we have this code for just controlling a light, we just replace this idea of controlling a light with whatever we want to do. Like if I wanted to make something unlock the door, I'd replace the LED with like a servo motor to, say, work the mechanism to unlock the door. So I just wanted some bare bones code on how to do that, and I can show you the wiring diagram for this, and then some places where I got the base code that I did from a really good GitHub file. So I'll put the link in there and show you where to go for that. Okay, so just really quickly, if you want to know the basics on this, of where to get some very helpful Arduino codes, if you just go to Google, basically put in RFID and Arduino, a whole bunch of things come up, and almost all of them go back to this particular GitHub. But I originally found it through Arduino. And then we have the GitHub right here. I also just followed the link from the files that I have. You can download this into a zip folder. Once you have it in your zip folder, what you get once you extract the zip folder, what you'll get is this RFID system. Just somewhere in here. Oh, RFID master. There it is. Okay, so you get RFID master. It's going to have a library. These two guys, which it's going to call on. Then you have a lot of examples. So if you're very to Arduino, what you want to do is open up any one of these. Probably not the best example, but let's just pull up one of these. This is for the laser tag guy. And this is, you go to your sketch, include library. It calls it add a .zip file, but yeah, you can extract it first. And then you go through your directory to find out where you just pull up that folder where it was saved. And then from there, it's going to, it just has a folder. I mean, mine, it's going to tell me that I've already done it, so it's not going to do it again. Or one of the subfolders in there wasn't right. I guess I didn't quite get the right one in there, but at any rate, yeah, you can do that one. I did have some trouble with that. Some stupid problems, because I loaded up several libraries. What I would suggest you do if you have a problem is like, because I had problems where for some reason, I had an old link basically to this one that wasn't updated, so there had been some changes to this file. And then the one that I did didn't have the updated changes. For some reason, could never get the Arduino to open the proper folder. So I literally just came in, took this, copy and pasted it into the old folder, and then just uploaded it again. So yeah, I just copied it, pasted it into the other folder, and it seems to work just fine now. So if you have problems like this one says like the subfolder is not a valid library, just seriously copy and paste this into a folder that does work. There you go. You're done. And then it doesn't have to be as frustrating as it gets, because it gets really fucking frustrating. Okay. Once you have these examples, once it works, which is nice, you can, basically there's a lot of different codes, I love them, but then you can go and mine them. So I was particularly interested in UID and also this one. But in the beginning, what you'll have of information on there, and include the most important things, which is this pinout. And then we're going to go, because I'm going to show you the circuit that I did, but so following the directions in that code, which turns out to be a very important thing to do, what I'll do is make sure that we hook this up right. So I'm assuming that you're using this RFID-RC522, but the other ones, they do have this written down. So what you have on this card is you have 8 different pins. So we have S, D, A, and that one goes to pin number 10. There are some other ones. Some, I don't know if they're newer or older. It's called SS. So it's the slave select, because this is a master slave circuit. So there's one circuit that, one is controlling the other one. Which, that's a little bit more for me to go into off the top of my head. Okay, they have SCK. I didn't realize how much it looks like just suck there. That one goes to pin 13. Then we have master out, slave in. So MOSI, master out, slave in, goes to 11. Then we have in slave. Oh man, it's just sounding dirty now. That's 1, 2, 3, 4. Master in, slave out is number 12. Okay. Then next we have IRQ. For what I'm doing, this is nothing. It's empty. I don't have it connected to anything. I'm sure there's other programs that do, but I don't. This is a ground, so that goes to ground. And you can just get to ground on the Arduino or ground in the circuit. Then next is reset. This one, I think I'm going to 9. Yes. This one goes to 9. And then I have 3.3 volts. This to the Arduino, 3.3 volts. I know it sounds really dumb when I say it like that, but on your Arduino board you have a 5 volt and you have a 3.3 volts, and some things work off of 5 volt logic, other ones are 3.3 volts. This is 3.3 volts. I don't know how much it's going to hurt your system if you don't have that connected. Okay. I'm just gonna take this really quick. Now we're going to draw the rest of the circuit. Those are all just slots on the Arduino. That's going to ground. Also going to ground, I have a resistor R1, a resistor which has the same value. That's going to be oops. And then I have an LED, and then I have another LED. This one is the red, this one the blue, and my red LED is going into pin 8, and this one's going to pin 9. So there is our whole circuit diagram, just to make an LED turn on and off with. Okay, this is the circuit diagram. I fixed it so that blue is 7. This is the circuit diagram that we want. Okay, so let's take a look at the code. So again, this is just going through examples in the RFID master. I pulled up the read in UID. And this is the RFID reader MFRC 522 library from Balboa. I'm not sure if I'm saying his name right, so I'm sorry about that. Or Balboa, yeah. I probably shouldn't really try to say it. Balboa. So then it has the pin readout, which we went ahead and drew out. Then you have to include these libraries here. So you can do that by going to Sketch, Include Library. and I could include, see, this is where I had to reload it, and yeah, there's just other ones I tried. Or you can just type it in, and then we're defining, this is just a little bit of a different way that he does it. We had it before where we would write like int ss pin equal 10. That's the same thing as this, so I just leave it that way. And then this is the, well, I guess he writes it instance of this class, so this is what it is. So when we say MFC522, what we mean is an RFID that has pointing to the pins that it is. So we're saying we want to go call on pin 10 and pin 9 there. This is the type of key that it is. The information is in bytes, and we have 4 different, I guess you'd say, columns. So we start from 0, 1, 2, 3. So that's where we get the 4. This one has serial.begin 9600 is just a call on the serial port, so we can watch what's going on, which is really helpful when I was trying to modify the code too. And then we want to initialize the SPI bus, and we want to initialize the MFRC522. These are calling on functions in these other .h files. So if you open up one of those .h files, you'll see these things. These are defined inside there, and we're just calling on them, which is actually really nice. This is just so we can read it. For the setup. So we want to read it in this particular format, going from 0 to 5. So there's going to be 6 integers, increasing the integer as we go. I guess that's the hex key that's defining the card. And then this is still an initialization, so this is just printing something to the serial port. We want to print this, and we want to print this, and then you want to print this key byte, the hex, which we have up here, and the key size. And there's different types of ones. I believe that these are, well, we'll see it in a second, but there are different readers for different size of cards. I guess these can hold more information than the other ones. It's not really something that I was too concerned about. Now we have a function, we want to look for new cards. So we're asking the program to, constantly be asking this antenna, is there anything there yet? Is there anything there yet? If not, so this exclamation point means if not new card present, then we return, then we go back up to the beginning. If we are not reading a serial card, then we go back up to the beginning. So this is just looking to see if there's a card there, and we're looking to see if we've read anything. If we have not read anything, or have not found a new card, we just go back up to the beginning. Okay, then inside this loop, this is the main loop, we want to print PICC type. That's just going to print these words to the serial monitor. And then what we have here is from what we defined, this MFRC522, which we say up here what it is, right? Then we want to say that this part, the PICC type, equals RFID dot get type. So since we said it's RFID, we have these functions again in the library that are like PICC get type, and then we have this, I suppose the coders say passed into there. So if we want to use this function that's in the library, we say RFID dot, because we called it RFID up here, because we defined it to be that. You could call it Bob if you wanted, but that'd probably get confusing. Then we want to print the get type name. So what is that type? This is telling it to ask it what type, and this is saying that we're going to print what the answer is. Now we want to check if this PICC is of basically the type that we want, the classic MeFair type. So if it is not this type, which I believe this is the type of card I have, if I remember right. If it is not this type, then it will print that your card is not of type MeFair Classic. So that means that this is not, the type of card that we would be using with this receiver. Now, then we get into the UID bytes. This is those 4 digits. And these are identifying which card is which. So all this code is saying is that if this byte 0, this one of the scanned card, does not equal, so it stores this byte in the computer after it reads it, and if this is not equal to the new scanning byte, and then same for all 4, then we say a new card has been detected. And then here's where we're storing this. So we're storing the new UID into new UID PICC array. And then for starting from 0 to less than 4. See, those are the integers 1, 2, 0, 1, 2, 3. Then we have this new UID PICC integer I equals this guy. So this is actually the line of code that's storing that information into this. And then when it checks a new one, it's basically checking if we've read the card. Then we have the serial print command to say the in UID is blah blah, and then we serial print in hex, and then we print this that we stored and the size, and then we print in decimals, we print this and then the size. So it's just 2 different ways to give the same information. Otherwise, so if this is not true, if we did scan it before, if byte 0 equals the read 0 and blah blah blah, otherwise we print this card has been read previously. And then this is just stopping it from reading continuously, which we can play around with too. So here, let's go ahead and upload it. Since it will work with my circuit, it just LED isn't going to do anything. And then we can open up the serial monitor and then take a look at it and see what it's doing. And then everything, use the LEDs is not, certainly didn't need all of this. Okay. Yeah, see how it doesn't like the COM ports. So we also have a couple functions here at the end, which is just print hex and print decimals. And we called on them here. So that's where that print hex comes from and print dec comes from. Those are not standard Arduino programming functions. Those were defined here. Okay, so let's open up serial monitor. And I'm going to go ahead and scan. So that's just the initialization code that pops up there. I'm going to scan the blue tag. Alright, then if I scan the blue tag again, it's going to check to see, does this number that it scans again match this number that it stored just now? And it says that the card's been read previously. but we can see a little bit of a thing with that in a second. And I'm going to take the white card, and that says a new card's been detected, and it has a different ID. So that's different. Now if I take the blue one, I can scan it again. It's not, because it's only storing, it's not storing this number indefinitely. It's just storing it after it's been read. Once it reads a new one, once it reads a new card, it forgets all about the previous card, which there's got to be like some sort of like Donald Trump joke in there, or somebody who marries a lot of young women. Anyway, yeah, they only remember the last one. They don't, and they're always looking for something new. As soon as this code sees a new card, it forgets all about the previous card. Okay, now what I wanted to do was I wanted to take this is the white card. This is the blue tag, and I wanted to have something where I could only use the blue tag to make the red one go. Okay, so this is my code here. The only thing I added, I took a lot away. I added the blue LED pen, and I added the red LED pen, and I kept all these other instances here. In my setup function, I still had to initialize the card, so I had to initialize reading the RFID, and that's how I defined it here. So there we go, I define it up here, and then I do RFID dot initialize function. And then I still want it to be able to read those bytes, so I left it in there. Okay, now the loop, I want to look for new cards. This is another function from that library. Is the new card present? So I want to see if it is. If it's a new card, and if we've read it. It said read it, but it's okay. And then we have our get type there. Now, instead of saying if this equals, before it was if this doesn't equal what we just read, I just put in the numbers. And it's probably not the best way to do it, but yeah, I just put in the numbers. And then when I was working out code, because I'm not very good at, a coder by any means, I do try to just be able to do enough to make something work and be able to explain what I'm doing, so that then later I can get help with the code, make it do something in a better way. So this is really helpful when you're trying to do that. It's also helpful to just like have light go on and off. But yeah, so first I could, just type it in there. Okay, that's a good card. And then my red light goes off. And then if I do the white card, it still comes up with good card. But we can change this too. Let's change that to read blue tag, and this one to read white card. Probably got that backwards, but then I'll upload it, and then I can test it to see if I got it. And then we'll see, did I do it right? And then, I have a nice. So then it's nice to see, if I scan the white card, the blue tag, I can see which one I'm scanning, and it just prints that for me, which is really nice. Then I know what to put in. I did get them backwards, by the way. These lines here, they just make it so that it reads it once and then stops. So if I like for instance for the laser one, I didn't want it to just read and then stop like it was doing. I wanted it to keep going. So, and not do that line of code, just keep going. So this is a very simplified version of the other code. But it does what I want it to do. Was pretty much the idea. So I'm just holding the card in front of it. And it's a little slow because it has a delay written in there. But instead of just stopping, now if I just hold the tag in front of it, it'll just keep going because I've commented out the halt lines. Anyway, I hope that's helpful. Just for someone who wants a really simple RFID to control something like, say, turn on a light circuit, and you really just want the bare bones. There are some really good like videos and tutorials on explaining all the details of the RFID and how it works. So I didn't really feel like it was necessary for me to go into that because there's people that have explained it better. But I hope that's helpful. Now I'm going to go show you how to the circuit and we'll put it together again. So I'm going to go ahead and show you how to build this circuit. And hopefully we'll see that this is not very hard at all. It looks confusing because there's a lot of wires, but it's really not so bad. And you see, I finally couldn't take it anymore, and I started using like just different wire colors. Okay, so the first thing we have in our circuit is this guy, and I'm gonna start. I wrote down the pins in my circuit diagram in the order that they show up here. There are different cards that have these in a different order. So first one, oh, and if you do get this, you will have this pin. When you first get it, you just have to solder it on by hand. So it's not too bad though. Okay. So the first one is SDA, and I'm gonna go ahead and put that in 10. Alright, next is SCK, which now all I can see is suck. Then we have master out, slave in is going to 11. And then we have master in, slave out is going to 12. IRQ is next. That one's empty. Ground is here, and I'm just gonna take that to a rail. And I will do that over here because I'm later gonna want the LEDs to go into ground too. And then reset is going into 9, and then I take a longer guy here, and I'm just going to plug this one 3.3 volts straight into 3.3 volts. So on the Arduino we have this ground 5 volts and then 3.3 volts. I don't think it's safe to put it into 5 volts. You know, it's easy enough. Why bother? You don't need to mess around with that when you don't need to. I've heard people say that it's safe, but I'm not sure how much you really need to trust that. Okay, so here's our blue. That's our positive end, and blue I said goes to, oh, you know, I made a mistake in there. I said blue went to 9. Let's say blue goes to 7, I think. I'll write a note in there because I totally wrote that wrong. Yeah, so blue goes to 7. And then let's hook up that resistor to ground. Red. And red goes to 8. Let's get our resistor. I'm just using a 560 ohm resistor. I guess I didn't specify that in the diagram either, but it's really not that important. I mean, as long as you have something in there to reduce the current a bit. Okay, so then that one's going to ground, that's going to ground. Let's just stick this other wire in here, and we're going to have it go to ground. Okay, now I'm going to upload the program. I think I already forgot which is which. I know I wrote it wrong in here. So the blue tag should make the red one light up. Ah, I was right. Okay, and then the white tag, white card, should make the blue LED light up. And there we go. So that's pretty easy. I mean, it's easy after you've done it once. I mean, it took me a long time to get there. So after you're done, it feels like it was easy. The process is maybe not so easy, but I hope this helps other people to get there faster than I did, certainly.